வி மீடியா சேனல் சார்பாக அனைவருக்கும் வணக்கம். நம்முடைய அடுத்த பதிவினை நோக்கி நகர்வோம். ஒரு கதாநாயகனுக்காக காத்திருந்தது போலாகிவிட்டது. கடந்த ஜூலை 12ஆம் தேதி வெளியிடப்பட்ட பதிவுகள் யாரிடமிருந்து ஒரு கதாநாயகன் இந்த பூமியின் நெற்றிக்கண், ஆன்மீகத்தில் சொல்லப்படுவது போல நெற்றிக்கண் ஒரு தொலைநோக்கி, ஜேம்ஸ் வெப் என்கின்ற தொலைநோக்கி வெளியிட்ட பதிவுகள் அண்டத்தை குறித்த கேள்விகளுக்கு ஒரு பெரும் உற்று நோக்குதலை ஏற்படுத்தியிருக்கிறது. நாம் இந்த பூமி எங்கிருந்து தோன்றியது, நாம் எங்கிருந்து தோன்றினோம், இது குறித்த ஆராய்ச்சிகள் தொடர்ந்து நடைபெற்று கொண்டேதான் இருக்கிறது. பல்வேறு முடிவுகள் வெளியிடப்படுகிறது. ஜேம்ஸ் வெப் பதிவு செய்த பதிவுகளை காணுங்கள். அதை காணும் பொழுது தெற்கு வளைவு நெபுலா என்று ஒரு பதிவு இருக்கிறது. நம் கண்ணை பிரதிபலிப்பது போலவே அது இருக்கும். அற்புதமான படங்கள். அண்டத்தில் நாம் ஒரு பால்வெளியில் இருக்கிறோம். ஒரு சிறு துளியில்தான் நம்மளுடைய சூரிய குடும்பம் உழன்று கொண்டிருக்கிறது. அது குறித்த ஒரு காணொளியும் இந்த பதிவில் இணைக்கப்பட்டிருக்கிறது. சூரிய குடும்பத்தில் உள்ள கோள்கள் குறித்தும் நம்முடைய பூமி குறித்தும் சில தகவல்கள் இந்த காணொளியில் இணைக்கப்பட்டிருக்கிறது. அதற்கு பின் இந்த பிரபஞ்சத்தை நோக்கிய ஆராய்ச்சி எப்படி போனது, யாரெல்லாம் அதை முன்னெடுத்து சென்றார்கள் என்ற காணொளி இணைக்கப்பட்டிருக்கிறது. மூன்றாவது காணொளியாக இந்த ஜேம்ஸ் வெப் அனுப்பிய பதிவுகளை வைத்து நாம் என்ன முடிவுக்கு வர முடியும் அப்படி என்கின்ற ஒரு சிறு காணொளியும் இதில் இணைக்கப்பட்டிருக்கிறது.
Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own Sun. Revolving around the Sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system since that is where the gravitational and physical influences of the Sun end. Our solar system's particular configuration of planets and other celestial objects
We have taken more than thousands of photographs of the different galaxies from our Earth. But we have to leave and travel outside of the Earth to take a photograph of our home galaxy. And the travel distance is 3 lakh trillion kilometers. At this distance only, we can get the right angle to photograph the whole Milky Way galaxy. An object made by humans which has gone far from the Earth is the Voyager 1. Launched in 1977, it has been traveling at speed of 61,000 kilometers per hour and covered a distance of 21.2 billion kilometers so far. This means that it would take 562 million years for the Voyager 1 to leave the Milky Way and take a photo at the correct angle, even traveling at 61,000 kilometers per hour speed. Let's look at what the galaxy is before to see how we got this photograph. Within a galaxy there are stars, planets, meteors, nebulas, dust clouds, black holes and more. We can classify them by the shape. Spiral galaxies, elliptical galaxies, lenticular galaxies, irregular galaxies, and some other shapes. Moreover, most of the galaxies in our universe are spiral and elliptical in shape. Our Milky Way galaxy is a spiral type which has a diameter of nearly 1 lakh light years. This means that if we travel at the speed of light from one side of the Milky Way galaxy to the other, it takes 1 lakh years to cross. From the Earth, we can see some parts of our galaxy, and we can enjoy its beauty on clearest, darkest night. It would be disappointing if you tried to see this from cities, because cities have light pollution. Even the stars seen on that pollution-less night are just 0.0000025% of the Milky Way galaxy. Research on the galaxies has been going on since Aristotle period. Galileo Galilei was the first to discover that the galaxy is a bundle of stars. In 1785, British astronomer William Herschel divided the sky into 600 parts, counting the stars in each region and drawing a map of the structure of the galaxy. That's Herschel map. In 1900, Jacobus Kapteyn also did some research to confirm that the Herschel map was correct. In 1910, a woman astronomer Henrietta researched the luminous nature of the stars and also made a structure map of our galaxy. Then, in 1917, Harlow Shapley explored galaxy and said that we in our solar system are not at the center of the galaxy, we are too far from its center. At the end, current research also confirmed that he was correct. Then, in 1920, Edwin Hubble explores space with his telescope to discover that there are countless galaxies in the universe, and that we live in one of them. Thus, research on the galaxy continued. Today, astronomers have found out the entire structure of our Milky Way galaxy, and where we are in it. Well, how did they find out? For example, we are inside a house, but we don't know what the outside structure of the house looks like. How to know that? Even if we can't know the entire outside structure of the house, we can know to some extent. If we open the window of our house and know what kind of structure the near houses are, so we can also know the approximate structure of our house. Similarly, there are billions of galaxies around us, and by examining those galaxies, they predicted that our universe would also be in a certain shape. But that prediction is more accurate. Most of our universe things are in two shapes. One is a spherical shape and the other is a flat disk shape. Planets, stars and asteroids are all spherical in shape, while spiral, elliptical, and some other galaxies are in flat disk shape. So it seems certain that our Milky Way galaxy is also in the shape of a sphere or flat disk. Moreover, based on long-term data, astronomers believe that our Milky Way galaxy was supposed to be flat in shape. With the help of more than 50 years of continuous research and observation of movement of stars, radiation from it, cosmic rotation, they made a map of our galactic structure. Also, they continuously find out and keep updating where the nebulas are and where new stars are forming. Yes, of course, no one has photographed our Milky Way, it's just artwork. But this artwork was not drawn by imaginary, with the information that has been collected continuously over the years, based on the mathematic calculations and accurate observations. Now let's understand our Milky Way structure simply and briefly. Our Milky Way galaxy is a barred spiral galaxy. That means there will be a bar-like structure at the center of this. There are about 10 million stars around in that bar in just 1 light-year distance. From this galactic center there are 2 important arms that make a spiral. One is Scutum Centaurus arm, and the other is the Perseus arm. Both of these are the main pillars of our galaxy's spiral shape. And there are 3 medium arms in the space between those 2 arms. Sagittarius arm, Norma arm, and outer arm. One arm branch comes from Sagittarius arm, that name is Orion Spur. Its length is 10,000 to 20,000 light years, at the center of which we in our solar system are located. Our solar system is located 26,000 light years from the galactic center. Well, if we have to look close at our Milky Way galaxy, it seems that only its arm has more stars, and there are no stars or less on its outside. But the stars are spread evenly in both areas, but in the arms there are more nebulas spread out, so that it looks like that. Nebulas are full of dust clouds which create new stars, that's why that place is more dense. Just as our Earth orbits the Sun, so does the solar system orbit the center of the Milky Way. Earth takes 365 Earth days to fully orbit the Sun once, while the solar system takes 214 million years to orbit the center of the Milky Way, with the speed of 230 kilometers per second. Scientists estimate that the Sun has orbited only 18 times since it was born. And the rotation of our galaxy, the number of stars in it, the movement of these are not yet fully understood. It may take thousands of years to fully understand our Milky Way galaxy. At its center is a very large black hole. Its name is Sagittarius A, almost 1 billion times heavier than our Sun. This black hole, which was initially small, may have become larger over time by absorbing stars and dust gases. A recent study found that one of the arms of the Milky Way galaxy is broken, a new arm branch may form from that. And as the moons orbit the planets, 2 smaller galaxies orbiting our Milky Way galaxy. Astronomers say that our galaxy, which is currently in the shape of a spiral, could become circular in a few billion years due to the angular momentum. Or that the nearest galaxy Andromeda could collide with our Milky Way galaxy. If you doubt there will be a great explosion when the stars of the 2 galaxies collide with each other. No, there is no possibility of that happening. The reason is the distance between the stars. The stars are not as close as shown in the movies. Although the stars appear to be near, the distance between the 2 stars is billions of kilometers. For example, the distance between our Sun and the nearest star Proxima Centauri is 40 trillion kilometers. And scientists say that the merging festival will not happen overnight, it would take billions of years. That only 3 or 4 of the 1 trillion stars in the 2 galaxies are likely to hit each other. Although we cannot take a real photo of our Milky Way, we do have several photos of the Andromeda galaxy. Similarly, someone in Andromeda may have photographed our Milky Way, if they could not photograph their own galaxy? Who knows? But space is strange.
ஜேம்ஸ் வெப் பதிவுகளை மாத்திரமே கொண்டு செய்யப்பட்ட ஆராய்ச்சியின் முடிவுகள் இந்த காணொளியில் இணைக்கப்பட்டிருக்கிறது. இதை தாண்டி ஒரு கேள்வி நிற்கிறது. அண்டம் விரிவடைந்து கொண்டே போகிறது. இன்னும் மேலும் 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 ஆராய்ச்சி செய்ய வேண்டியிருக்கிறது. ஆனால் இதை உருவாக்கியவன் யார்? இந்த கேள்விக்கு மாத்திரம் விடையே இல்லை. பார்ப்போம், காலம் பதில் சொல்லட்டும்.
Here are the James Webb Space Telescope images of the ancient universe. The James Webb Space Telescope has changed the way we observe the universe. Here are its first images of deep space, an unprecedented view into the past, almost 13 billion years ago. The first images from NASA's James Webb Space Telescope were published on July 12, 2022, proving the telescope's unique capabilities and changing the way we explore space. The images of the JWST
பிரமிக்க வைக்கும் உடுத்திரல்களின் அற்புத காட்சிக்கான
images of the JWST included a spectrum analysis of a distant exoplanet and 4 stunning images of the ancient universe, including the Carina Nebula, the South Ring Nebula, Stephan's Quintet, and SMACS 0723. As promised, 4 more full-color images have been released for the telescope's debut following the presentation of the deepest image of the universe taken ever, which essentially offers humankind a view of the universe as it was some 13 billion years ago, or other words, a look into the past. Nearly 7,600 light-years away in the constellation of Carina lies the Carina Nebula, one of the brightest and largest nebulae in the sky. Stars form in nebulae, which are stellar nurseries. Several times bigger than the Sun, numerous massive stars are found in the Carina Nebula. Webb's image reveals previously hidden baby stars behind the dust and gas on this nebula's cosmic cliffs. In the new view, the early stages of star formation can be seen for the first time. In the case of an individual star, this period lasts only between 50,000 and 100,000 years. The James Webb Space Telescope has detected the presence of water and clouds and haze in the atmosphere of a hot, puffy gas giant planet orbiting a distant sun-like star. Image credits: NASA, ESA, CSA, and Stsci. Although this is not a photograph of the ancient universe, it is one of Webb's most significant images. There is a giant gas giant planet called WASP 96b far away from our solar system. The planet orbits its star every 3.4 days, nearly 1,150 light-years away. The discovery of this planet was announced in 2014 and it has about half the mass of Jupiter. The spectrum analysis of Webb confirms the unmistakable presence of water, indications of haze, and cloud evidence, which was ruled out previously. An exoplanet spectrum with this level of detail has never been observed before. Furthermore, Webb captured a light curve showing the brightness of WASP 96b's parent star over time. A planet's light dims as it transits a star's disk. In spite of the fact that WASP 96b's characteristics were known, Webb's measurements provide more detail. New planets can also be discovered using transits. Known as the Eight Bangs Nebula, the South Ring Nebula is an expanding cloud of gas surrounding a dying star. Approximately 2,500 light-years from Earth, it is almost half a light-year across. The faint, dying star in the Webb image is ejecting gas and dust, which the telescope could observe with unprecedented detail. Webb reveals dust covering the dying star for the first time. The delicate gaseous layers will dissipate into space after thousands of years. Stephan's Quintet lies in the constellation Pegasus approximately 290 million light-years away. This galaxy group is notable for being the first compact group of galaxies ever discovered. A cosmic dance of repeated close encounters is taking place among 4 of the 5 galaxies of the quintet. The Stephan's Quintet image by Webb shows 5 galaxies, of which 4 are interacting. In the foreground is the galaxy on the left. With a diameter of about a fifth of the Moon, this mosaic is Webb's largest image. There are more than 150 million pixels in it, and nearly 1,000 separate image files make up the image. This galaxy group reveals details never seen before with Webb's powerful infrared vision and extremely high spatial resolution. Starburst regions of new star birth can be seen in the image, along with bright clusters of millions of young stars. Due to gravitational interactions, several galaxies are producing sweeping tails of gas, dust, and stars. An even more dramatic scene was captured by Webb when one of the galaxies, NGC 7318b, was caught passing through the cluster, sending shock waves through the cluster.
அடுத்த காணொளியில் சித்தர்கள் பார்வையில் அண்டம் பார்ப்போம். அதேபோல் இந்த பூமியை குறித்த பல்வேறு ஆச்சரியங்களும் மற்றும் கேள்விகளுடன் உங்களை மீண்டும் சந்திக்கிறோம். நன்றி.